Studies Section 9, Correlation and Regression. Introduction. In this study session, you will be introduced to correlation and regression. Correlation describes the strength or degree of closeness between two variables, while regression locates two variable data in terms of a mathematical relationship. This relationship can be in form of a curve or a line. When only two variables are involved, we have a simple regression, while when more than two variables are involved, we have multiple regression. Learning outcomes for study section 9. At the end of this study session, you should be able to sketch scatter diagrams that show the different types of relationship that exist between two variables. Discuss the Spearman's rank correlation coefficient. Regression analysis. It is the study of the relationship between two or more variables, and its purpose is to determine whether a relationship exists between the variables. If it exists, the relationship can then be expressed by a mathematical equation which will then be used to predict or estimate the value. Scatter diagram. The first step in determining the type of relationship between two variables is the geographical plot of y, vertical axis, against x, horizontal axis. The variable y represents the dependent variable, while x represents the explanatory or independent variable. Shapes of scatter diagram. When the values of y are plotted against the values of x, we can have the following: positive linear relationship, negative linear relationship, negative curved linear relationship, positive curved linear relationship, no relationship. Method of fitting the line of best fit. There are three ways of fitting the line of best fit, which is also known as regression line. 1. Freehand method. 2. Geographical method. 3. Method of least squares. Freehand method. This is a subjective method of fitting a line. It depends on the observer. There is no unique line since it depends on individual judgment. Hence, such lines should not be used for prediction or forecasting. Graphical method. It shows that the regression line must pass through the point represented by the arithmetic means of the two variables. The means of the two variables are obtained. The pair of the values x, y on the scatter diagram, then a straight line is drawn through the point. It is exact, but the stronger the association, the more reliable the method. The method of least squares. The method of obtaining the line requires that the sum of squares of the deviations from the point to the line of best fit is the minimum. The basic assumptions are: 1. The mean of the error term is 0. E into bracket E I is equal to 0. 2. The variance of the error term is equal to variance. 3. E is similar to n into bracket 0 variance in bracket. The regression line is given by yi is equal to a plus bxi plus e, equation 1, where yi is the dependent variable, a is the intercept, b is the slope or regression, ei is the random error term. By the basic assumption, e into bracket ei is equal to 0, equation 2. Then y is equal to a plus bs, equation 3. To obtain the expressions for a and b, that is, the intercept and the slope, using equation 3, y is equal to a plus bx. Multiply equation 3 by n. Summation y is equal to na plus b summation x, equation 4. Multiply equation 4 by x. Summation xy is equal to a summation x plus b summation s squared is equal to equation 5. Equation 4 and 5 are known as the normal equations from which we can obtain values of a and b. Summation y is equal to na is equal to a is equal to equation 6. Just like simultaneous equation, Put equation 4 in 5. B summation s squared is equal to B is equal to B is equal to B is equal to cross multiply. B summation s squared is equal to, collect the like terms, B into bracket summation s squared minus n x bar squared is equal to B is equal to x bar is equal to y bar is equal to, therefore B is equal to. Example, the table below presents effect of drug X and recovery rate Y. A. Obtain the regression line of Y on X. B. Obtain an estimate of Y on X when X is 60. Solution. Instead of going through the rigors of having a table whereby you obtain xy, x squared, y squared, then sum all these, you can use your calculator Casio FX991MS. The first step is press the mode twice, then comes out. Press 2 to pick regression. Then calculator flags. Since we are dealing with linear regression, press 1. With this, you can now input your data by pressing 20 and, which is beside memory plus, then press 8.4 and memory plus. Immediately n will be equal to 1. Comes up. This implies you have saved the first data. Repeat for all the remaining 11 data. To obtain the necessary result of the stored data, press shift and 1, then comes up. Press 1 for, then press is equal to, summation s squared is equal to 12,104. For summation x, press shift 1, then 2 is equal to, summation s is equal to 372. For n, press shift 1, then 3 is equal to, n is equal to 12. For summation y squared, press shift 1, replay. Then comes up. Press 1 is equal to, summation y squared is equivalent to 2149.19. For summation y, press shift 1, replay. 2 is equal to, summation y is equal to 153.3. For summation xy, press shift 1, replay. 3 is equal to, summation xy is equal to 5045.3. Follow the steps. It continues like that. We can now obtain A, B since we have all the values. B is equal to 0.5121. A is equal to minus 3.0990 is equal to minus 3.0990 plus 0.5121. Although you can pick the values of A and B directly from the calculator, you are expected to show the calculations for A and B, otherwise you will be penalized. For exam purpose, you can only use the values to check your results. The values of A and B can be obtained from the calculator by pressing B is equal to 27.6270. Precautions when using a calculator for regression. 1. Always check that n is equal to 0 before you store your data, or press shift mode 3 is equal to twice. 2. When you want to regress y on x, store the data as xy. Scatter diagram. The linear correlation that exists between variables can be A. Perfect positive correlation R is equal to 1. B. Perfect negative correlation R is equal to minus 1. C. Partly positive correlation 0 less than R less than 1. D. Partly negative correlation minus 1 less than R less than 0. E. No correlation R is equal to 0. Pearson product moment correlation coefficient. The correlation coefficient is given by the sign of R indicates whether there is a direct or indirect relationship between the variables. Example, compute the Pearson's correlation coefficient between x and y using the table in 9.2.3.1. R is equal to 0.8867. The value of R can be obtained from the calculator by 1. Store the data, 2. Press shift, 2. Replay twice, 3 is equal to interpretation. There is a very high direct relationship between the two variables. Spearman's rank correlation coefficient. This is most applicable when the population is not normal or the distribution of the population is unknown. It can be used for variables such as intelligence test, taste, color, and so on, especially qualitative variables. In rank correlation, the ascending or descending order of magnitude can be used. The steps are as follows. Assume we are using ascending order. 1. Rank x and y by assigning 1 to the smallest and n to the largest. 2. Compute the difference between rank x and y. D is equal to Rx minus Ry. 3. Compute the Spearman's rank correlation coefficient. RSP is equal to 1 minus 6 summation d squared over n into bracket n squared minus 1. Example. Using the table in the example above, we have when 2 or more observations have the same value, the rank is determined by taking the average of the ranks. R is equal to R is equal to 0.9161. This indicates a high positive correlation. Summary of study section 9. In this study session, you have learned that 1. Regression analysis is the study of the relationship between 2 or more variables, and its purpose is to determine whether a relationship exists between the variables. 2. The method of obtaining the line requires that the sum of squares of the deviations from the point to the line of best fit is the minimum. 3. The scatter diagram Pearson's product moment correlation coefficient and Spearman's rank correlation coefficient are usually used to study the linear correlation. 4. The correlation coefficient is denoted by the letter R, and R lies between -1 and 1, that is, -1 less than or equal to R less than or equal to 1. This is the end of study section 9. Thanks for listening.